Let's look at some problems on Poisson distribution. Problem number 1. If m is the variance of the Poisson distribution, then the ratio of the sum of the terms in odd places to the sum of the terms in the even places is, first option, e power minus m into cot hm, second option, e power minus m into sin hm, third option, cot hm, and fourth option, tan hm. So, we know that the probability generating function or the probability mass function corresponding to Poisson distribution is e power minus m into m power x by x factorial, where x ranges from 0, 1, 2, so on up to infinity. This is the probability mass function corresponding to a Poisson distribution. We know this. Here m is the variance is given. Variance is also equal to the parameter value in a Poisson distribution. This we have learnt earlier. Okay, so m is the parameter value, or which is also the mean or variance. Mean, and that is equal to the variance in a Poisson distribution. All of them are equal. Now, in this summation, what is he asking? We have here summation of this e power minus m into m power x by x factorial, x ranging from 0 to infinity is equal to 1. We know this. Here this summation comprises of even position terms and odd position terms here. So, e power minus m can be taken out common. Now, we have m power 0 by 0 factorial, m power, next m power 2 by 2 factorial, plus so on and so forth. That plus we can take, I am separating out the even odd position terms and even position terms. This is term 1, this is term 3. Now, we have term 2 here, m power 1 by 1 factorial, term 2, and then term 4, m power 3 by 3 factorial, so on and so forth. We have terms like this. So, I have separated out the summation. The whole thing we know is equal to 1, but we are interested in the ratio of the sum of the terms which are in the odd position. So, this is what we are interested in, odd term sum. So, T1 plus T3 plus so on divided by T2 plus T4 plus so on. This is what we want. So, what is this equal to? We know that this is nothing but, this is going to be e power m plus e power minus m by 2 numerator. In the expansion of e power m, we know that e power m expansion is m power 0 by 0 factorial plus m power 1 by 1 factorial, so on and so forth, m power 2 by 2 factorial. Okay. E power minus m will have an alternating sign pattern. So, m power 0 by 0 factorial minus m power 1 by 1 factorial plus m power 2 by 2 factorial, so on and so forth. If you add these two, you will be getting odd position terms, double of the odd position terms. Whereas, if you subtract the second one from the first, you will get double of the even position terms. So, we have here e power m minus of e power minus m by 2. We know that this is nothing but cos hm, hyperbolic cos m, and the denominator is hyperbolic sin m. So, what do we have? It comes out to be cot hm. Now, the answer is, therefore, the answer is 3. Third option is the answer. Let's move on to the next question here. Question number 2. The incidence of an occupational disease to the workers of a factory is found to be 1 in 5,000. So 1 by 5,000. If there are 10,000 workers in a factory, then the probability that none of them will get the disease is, first option e power minus 1, second option e power minus 2, third option e cube, and fourth option e power 4. So let's look at the solution here. Now it's been given that probability of a worker having the disease is 1 in 5,000. And how many workers are in the factory? So this is our P. I told you earlier that Poisson distribution is a limiting case of a binomial distribution where P is small and N is large. Here P is the probability of success or getting a person, finding a person, worker to have a disease is P, probability that, and N here is the total number of workers that we are examining, that is number of trials we can say. So lambda, the parameter of the Poisson distribution, we said is given by NP. So that is 10,000 into 1 by 5,000, that's going to be 2. So lambda in this case, in our example, in this problem is 2. Now what is being asked? The probability that none of them will get the disease. So 1 minus the probability that the number of persons who get the disease is at least 1. What is x? The random variable which counts the number of persons getting disease. Counting number of persons having disease. So 1 minus the probability that x is greater than or equal to 1 will give me the probability of x equal to 0. Probability of x equal to 0 is what is required. The probability that none of them will get the disease, that is 0 number of persons have got the disease. So 1 minus the probability of x greater than or equal to 1. So let's go by what is the probability of x greater than or equal to 1. We will write this e power minus 2 lambda value into lambda power x, that is 2 power x, by x factorial, x ranging from 1 to infinity. So that makes it, this is going to be 1 minus of e power minus 2 can be taken out common, and here we have sigma 2 power x by x factorial, x ranging from 1 to infinity. And we know that this part in the summation part inside the bracket is close to e square, but one term is missing, because if had it been 2 power sigma 2 power x by x factorial, x ranging from 0 to infinity, it would have been e square. So but you don't have that, so what do we have? What do we do now? So we add and subtract 1 there. So this is going to be e square minus 1. So that makes it 1 minus 1 minus of minus e power minus 2. So that is e power minus 2. So the required probability is e power minus 2, and the right option is, answer is 2. Let's go by it once more. The probability of the worker having a disease is 1 in 5,000. How many workers are there? That is 10,000. So that gives us the number of times that experiment of finding a person who is diseased is done. So n is large, p is small, Poisson distribution, case of Poisson distribution, What is the parameter? Lambda is equal to n into p. So, we found the parameter. What is the probability mass function? E power minus lambda into lambda power x by x factorial, x ranging from 0 to infinity. Now, what is x there? The number of persons who are deceased. Capital X, values taken by capital X are small x's. Probability of x equal to 0 is what we require, and that is e power minus 2. So, let us move on to the next question on Poisson distribution. Problem number 3. Cycle ties are supplied in lots of 10. There is a chance of 1 in 500 for a cycle to be defective. Using Poisson distribution, the approximate number of lots containing no defectives in a consignment of 10,000 lots if e power minus 0.02 is given to be 0.9802 is first option 9,980, second option 9,998, third option 9,802, fourth option 9,982. So, let us have a look at this. Now, here the sample size is 10 and P, the probability of finding a defective, is 1 in 500. So, lambda here n into P, what is that? 10 by 500, so 1 by 50, which is equal to 0.02. So, lambda is 0.02. Now, what is the probability that the number of defectives is 0? That is in a lot of 10, what is the probability that there is no defective at all? So, that is going to be, we have already seen in the previous example, it is e power minus lambda. So, that makes it e power minus 0.02. Okay, now, this is for one lot. So, in one lot, what is the probability that there is no defective? Now, how many lots are we taking in the consignment? There are 10,000 lots. So, how many can we expect? 10,000 into the probability of x equal to 0 is the expected number of lots, with no defective. So, the number of lots which are expected to be non-defective will be 10,000 into the probability that the lot is non-defective. That is 0 number of defective items are there in the lot of 10. So, what is that? So, 10,000 into e power of minus 0.2, which was given in the tabulated form as 0.9802. So, I am just copying that 0.9802. So, that comes out to be 9,802. Therefore, the answer is 3.